So, Sandra is going to talk to us about, I think this one is a big part of change, which is the workforce and working with the organization. But of course, before we start, there is the important question of which is Sandra's favorite movie? So again, we have a very emotional, deeply emotional film called The Pianist as Sandra's favorite film. And I did actually ask Sandra, when did she first watch that film? And it was when she was 14.
I think I did a bit early.
So not that long ago. So
yesterday.
Yesterday. Thank you. So over to you, Sandra. Thank you.
Just before getting started, maybe one additional note about why The Pianist is as well one of my favorite movies. It's because it talks about resilience. And what we're going to discuss right now is all about resilience and being patient, which I'm not. A few mandatory things before we get started, and this is meant to build trust between you and I. Thank you. So this presentation is, of course, very much biased. So everything that I'm going to tell you is about gearing towards my own financial interest, of course. Few things to get started. So obviously, I think I don't have to convince anyone within this audience about the promises that machine learning and artificial intelligence holds all along the life cycles, from the early drug discovery up to regulatory, up to post-market, and so on and so forth. What I'm going to present for you today is really geared towards the drug discovery, the process development and CMC, and clinical developments. That's really where I'm focusing on. So I am part of the mRNA Center of Excellence within Sanofi, and some of the things that we're really doing is to develop this framework around build, test, and run all along the life cycle of our drug developments. So what we're really aiming at doing is to build this AI and machine learning, and obviously that requires trust. Trust from our scientists, because they are really the one that we're trying to go after. Why? Because without our scientists, we don't get the data that we need to build the AI and ML model, and we don't get the buy-in that we need. This is all about digital transformation. And digital transformation is not about technology. It's really about how the scientists adjust their work process, how they change their own routine. And it only happens with their buy-in. So we can get the biggest business case, we can get the nicest strategy, we can get whatever. If we don't have their buy-in, we are just not going to be able to make it. And it will take time. And as I said, I'm not the most patient person. So I really had to learn about how do we split the things towards making sure our scientists do have the time to adopt the things that we are pushing towards them. What I've done here is really based on theory, so really they're looking at different adoptions model that I'm going to share, as well as field-based, so really learning about the science, learning from experience. So some of the findings that I'm going to share are mainly fueled by the use case where we're currently pushing some electronic lab notebooks, some LIMS toward the scientists, and really understanding what makes them adopt or reject the system, as well as understanding what are the barriers and driving force to help them embrace data science and AI. Let's try to be in our scientists' shoes. So some of the things that are very important is that it's not a click, right? It's not one day they will wake up and say, hey, today I'm going to embrace AI. So there's a few prerequisites, and the prerequisites are actually very much on the change leaders, on senior leader, on top management, whoever. That's really the prerequisites that I will first dig into. But then we'll have three different phases for the scientists. We'll have the acceptability. Acceptability really talks about what is the subjective perception of someone who's just been introduced about the concept. They don't know anything about the technology yet. They just hear about the concept. The second step will be the acceptance, which is really the user perception once they've been introduced the first time to a technology. How do they react first? And the last step is about appropriation, so really about how they will integrate the technology within their day-to-day practice. If there's one thing that I've been learning throughout this journey is that there's only two places where you can really know where you are around this curve. The first one is being in the lab, obviously. I mean, you can do a lot of things. You can send survey, you can do whatever. If you really go in the lab, that's going to be a real eye-opener for some of you. The second place, coffee machine. That's where the real discussion happens. So the work that I'm going to present you is based on different common adoption models. So just to cite a few, you might find some very good cognitive understanding about the technology acceptance model that really gives a little bit of the theory around perceived, the perceived usefulness, as well as the efforts that we need to provide to adopt a technology. Or you can go toward the theory of the planned behavior that will really make a lineage between the attitude and the beliefs. So everything around the subjective perception, everything about how a user will perceive something as being fun or not. So that's really the theory of the planned behavior. Or the diffusion of technology from Davis, who is really explaining how a technology spreads and the different steps towards scaling a technology. I'm not going to go through all of them, but that's just to cite a few. So let's start with a little bit of the prerequisite. As I said, the first thing is to really make sure that the change leader or whoever is accountable for driving a change gives the prerequisite. And there's actually 6 conditions for change. The first thing is to have a case for change. We need to build a sense of urgency. If the leader, the change management, is not able to articulate clearly why do we need to change and why do we need to change now, it's not going to happen. It will end up with the statu quo. The second thing is about explaining clearly where we're going. So without this vision, without the where are we going clearly articulated, we'll end up to confusion. Skills. If we don't explain who is going to do this new technology, what's the training plan, how does scientists that are currently doing wet lab experiment can deal with automation, are they going to deal with data science and all these kind of things, we're going to generate anxiety. Incentives. So, of course, whoever is currently in a senior role is going to explain about what's the value for the organization. What we will see all along this presentation is that this is not enough. What scientists expect really is the what's in for me. I don't care about the company earning money. I don't really care about, is that going to help us being faster? I mean, of course they do. The real question for them is, help me understand how this is going to make my job easier, more interesting. That's really what we need to articulate. Resources, I mean, that's obvious. We don't want to generate frustration, so we need to make sure that we provide support, whether it's from a budget standpoint or whether it's from a resource standpoint. Our scientists are all very busy. So if we are asking them to deal with adoption, with change management, with learning new tools on top of their day-to-day, this is very difficult. one of the biggest takeaways I've been having is really about the importance of getting the right business analysts in the lab that are dedicated to help driving the flow, understanding what really goes into the lab to really be able to generate the change appropriately. And finally, of course, we need a clear action plan. I mean, we want to make sure that we trigger the right responses from our scientists. So that's really the prerequisite to start building this case for change. How is that being received by scientists? The first thing they want to hear about is perceived usefulness. As I said, if we are articulating a business case, which is really around this is going to help us reduce the cost, this is going to help us being faster, they don't see this end-to-end. So, of course, we need to articulate that, but that's not enough. What they want to hear is, concretely speaking, is that going to be useful for me? Is that going to change anything in my day-to-day? So this is not easy to articulate because obviously when we're trying to give a presentation to, Sanofi within the mRNA Center of Excellence, we're talking to 500 scientists. How do we make sure that we understand this perceived usefulness almost at an individual level? Well, this is where you need really to have people within the different lab. You need to have relay that can be your eyes and your ears to build this trust. The second thing is about the intrinsic or extrinsic motivation from scientists. They are scientists. So how do we use technology to help them advancing science? They are all very curious. That's something on which we can all build on. But the second thing which I found quite interesting as well is a correlation that we've been making around the MBTI personality test. And it was quite interesting to find out that actually we were almost able to make some very good correlation between some of the profiles from our scientists with the way they are reacting to technology. So for those who are not familiar with the MBTI, there's different type of things, but the biggest correlation is really on what we mean by introversion of extroversion, as well as sensing versus intuition. So the IS, so the one that are very much introvert and that are considered as sensing, would first ask you, tell me what's not going to change. Tell me, I need reassurance about what is going to remain stable. Only when they will be able to understand what is not going to change, then they can hear about what's going to change. But they need this reassurance first. The second type was really on the introversion and intuition. So they will need a lot of time to still think about the concept. They want to be involved in the brainstorming. They want to be involved into the vision. That's really where they want to spend more time before adopting your change. By opposition, the ones who are more extrovert are really about the, yes, let's do it. I want to get started. So they are almost already at the next steps. So extrovert and sensing are really on the doing. They are going to be willing to spend much more time on playing with the tool that you're throwing at them. So this one, the extrovert, are really already on the next steps. And finally, the extrovert, more with an intuition type of profile, are really about the let's change it. You know, you're driving a change. It's fun. I just want to see that change happening. So understanding a little bit the personality of your different scientists is as well a way for you to help understand, should you accelerate or should you slow down? The last thing on acceptability is the subjective norm. So the subjective norms is all about, am I encouraged to do it? Who around me is doing it? And how is it perceived? Is my management encouraging me to change? Is scientific communities expecting me to change? How would nature or whatever are the different type of papers that we're going to work with encouraging us to use different modeling as well? So this is really the first things around acceptability. Next steps, acceptance. So we are now putting a technology in front of our users. The first thing that is going to strike to the scientist is the attitude and the perceived usefulness. First things, most of our scientists, when they will be confronted with the technology, would tend to say, actually, okay, I understand where you want to go. I understand the need for standardization. I understand the need to go after fair data, but it does not really fit my needs. Can we customize it a bit? So that's really where we will really need to acknowledge that there's no one-size-fits-all. There's no off-the-shelf digital solution. So that's really the things that needs to be acknowledged as well. Depending on your strategy, you might want to spend the time customizing it or pushing for a standardized solution. Second thing, perceived ease of use. Yes, some technology requires a learning curve. Not all of them are easy. And we need to invest very much on UX. So whoever is currently developing ELN, LIMS, help us as well. We have a huge need for making sure that we can get our scientists adopting the tool in a much easier way. When you're a scientist and when you have to deal with an experiment, typing something out, that's just mission impossible for them. So it just doesn't fit their routine. So we also need your help here. The last steps will really be around the appropriation drivers. So once the technology has been presenting, once the training has been done, so now we are really in the day-to-day of the scientist. First question, usability confirmation. Okay, we have a technology. Does that really fit their day-to-day? What is the environment that they have to deal with? What's the accessibility, availability of the technology? What's the stability of the technology? There's nothing more frustrating for a scientist running off an experiment and simply not having internet connection. Basics. You've just lost your data. If you're working with data scientists, this is also super frustrating for scientists. They were trained as scientists. They were trained as being able to make conclusions out of their data. Now we're telling them, oh guys, wait a minute. Actually, we're going to ask our data scientists to also make conclusions out of your own data. That also requires quite a lot of change in their perception. And finally, the last point that I was mentioning earlier on is working with electronic device in a wet lab, whether you're in a NITEX environment or these kind of things. How do you do that? So of course, it requires new toolings, new environment, but that also needs to be taken into consideration from the get-go. And finally, the last step will be around the usefulness confirmation. Again, we've been hearing about making sure that the technology will get return on investment. Yes, but from a scientist perspective, this is all about, is that actually helping me being more efficient? And that's a big difference between what we've been hearing as well from the Galapagos presentation earlier on. The way we are doing at Sanofi is actually also a top-down and bottom-up approach, but from the bottom-up approach, we don't spend quite some time on going after the business case. What we go after is low-hanging fruit. Why? Because we are very much convinced that this is what is going to help us trigger the interest and the appetite and the trust from our scientists. With that, that's the end of my presentation, so happy to take any question if you have.
Merci, Sandra. Questions for Sandra? Oh, here we go. Yes, lots. Here come the runners.
Hi. Can you hear me? Yes, good. I'm Stuart Moody from Novo Nordisk, and it sounds like we have a similar organisation. In terms of user adoption and things like that, you know, if you meet lots of your other criteria in terms of usefulness, how important is usability, user experience, and things like that as an issue? I kind of, from my own anecdotal experience, I kind of feel expectations are so much higher now than they were, say, 15 years ago when people were using applications. I don't know what your feeling is.
Right. So the way we're currently prioritizing the use cases is really inspired from design thinking. So we are using the 3 criteria, which are desirability, where we are really trying to understand how many users are impacted by the problem, how strongly are they willing to solve it. So desirability, feasibility. Do we have the data that we need? Do we have the right technology? Whatever. And the last one is viability. Is the science mature enough for us to spend time solving this problem? Are the business processes already in place to be able to do that? Is that aligned with our digital strategy? So that's really basically the 3 criteria that we are really using to be able to prioritize it and take into consideration these 3 elements.
Excellent. Thank you. There was another question on the same table. If you could hand there we go. Shuttle it over.
Hi, this is Alessia from Lonza, and the presentation was very nice. I have a question about timing and expectations from management. So you mentioned a lot of this takes time. You need to build, the cases, low-hanging fruit. How do you deal with pressure from the management to deliver fast versus the time that is required to actually deliver that?
Yes, so this is where identifying your early adopters is really critical. So management will expect to have something fast indeed, and getting a first proof of concept with early adopter is where you can really demonstrate the value. And once you have this initial proof of concept or this MVP that is being built, that also helps those that are actually more, the introvert that we're seeing from the beginning, who wants to see something, who wants to see really how it works before being able to implement. So if you're thinking about how you're going to spread your technology across, that's really where you can get a first pool of people really adopting the technology, delivering the value, demonstrated really your return on investment before scaling that up. So build and run.
Thank you.
Okay, so the other questions we'll have to wait for, I'm afraid. We'll have to wait because we're now on time. Sorry, guys. You'll have to come and do that one. Thank you again, Sandra.